we couldn't point them at gigabytes of data like we can these days and have it go off and train from the data. We had to encode the thing ourselves, and that, based on what we're using, the technology we're using, was going to be difficult to really difficult. And so that's why AI had so much latency. In other words, they were a pain in the neck to build these things. So, what we're having today with the tools that are around today, I guess you kids, should appreciate that. But it's much better and much faster. I prefer the stuff we have today in 2026 and the stuff we had in 1985. But it's interesting to see the differences. So in 2026, AI is dominated by foundation models and machine learning that learn patterns from massive data sets, so capabilities scale with the data, compute, and model architecture rather than just how many rules a team can write. That captures the whole thing. In other words, the freedom of pointing AI systems at data and say, go learn from that data, whether it's supervised, unsupervised, what have you. And this is not going to be an AI class, but all the ways that we're able to train from the data, those are much more difficult, back in the 80s, even with some of the mainframe systems and some of the supercomputing systems that were around. The Cray XMP was around during that time. I used it. But it was vastly different in just the latency it took to get these things trained. And so that's what the limitation was. So, many people just threw up their arms. They say it was too much money, time, we can't do it. And they just moved on to other things, database technology, data warehousing, service-oriented architecture, rise of the internet, client-server computing, all that kind of stuff was just more attractive. And the trends flowed in that direction.